Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Pvt Limited. I have 14 years of work experience in the fields of artificial intelligence, software development and robotics. This video is part 2 for recurrent neural networks and long short-term memory networks. Tokenization and padding. Of course, you require to tokenize the thing. So I have included what everything means here. So first I will show you the code and tell you. So if you remember, I told you to keep the numbers and not the final labels for training the machine learning model, because the less data you have to train, less hardware you will require to train the model. So make sure you apply all these techniques to simplify the things. So let's see from here what tokenizer is and how it works. This line tokenizer, what it means is it initializes a tokenizer object from Keras, which will be used to convert text into numerical tokens. So it will be used for converting text into numerical tokens. And tokenizer, the tokenizer converts words in the text to integer values based on word frequency. So what word frequency is in simple words? So when you have some text, how are you, are you there? So here if you look for the word frequency, are 2 times, u are 2 times, and these are 1 times. So this is what word frequency is. So each word is assigned a unique index, and more frequent words get lower integer indexes. So indices. So this is what tokenizer will do. And num underscore words equals to 5000. What this means is, and where I have used it here. So what it means is this parameter specify that only the top 5000 most frequent words in the dataset will be tokenized. Top 5000 most frequent words in the dataset will be tokenized. So word beyond this will be ignored. This helps us to focus the most relevant words and reduce computational complexity. See, these words reduce computational complexity. Fit tokenizer on text. So what this means is line fits the tokenizer to the cleaned review column of the data frame which contains the pre-processed review. Yeah, before telling this, let me show you the charts and how they look like. So these will be the charts model when I run this training session. So what happens is it will show the model accuracy like this and model loss like this, and this will be the output that I have shown. So this is the thing that will show. Okay, so this will be the final output. I have already included it in the at last you can see the final outputs also and charts that I have included, and you can try running this code on your computer. It will run smoothly without any problem, I think. So let's see. Fit tokenizer on text. So the tokenizer learns the vocabulary of the dataset by analyzing all the text and building a word index. This index maps each word in the dataset to a unique integer. Tokenizer count word frequency and assigns indices based on their frequency. Lower index for more frequent words. So this is what this line is all about. Now converting text to sequences, this is the code, and what it means is this line converts the text reviews into sequence of integers where each word in the review is replaced by its corresponding integer index from the tokenizer word index, as I've told you in previous step. So they will be replaced with the that specific indexes. After the tokenizer is fit, each word in the review is mapped to its assigned integer. So a sentence like "this movie is great" might become this, where each number corresponds to a word in a tokenizer's dictionary. So this is what will happen, convert text to sequences. This is the code. So you understand, you cannot keep words here again and again. Using the numbers to represent the words makes much more sense to save the memory, because the data you will be dealing with in real world will be in GBs. So you will be getting 50 GB of data, 100 GB of data. How will you compute the data if you not apply standardization technique? So this is one of the things that is being done automatically by tokenizing the things. Then comes the pad sequences. You write the code like this. This line pads all the sequences. The reviews converted to sequences of number to ensure that they are of the same length. So what is happening? So you already know sentences are some sentences are big, some are small, and all those things. So this line pads all the sequences, that is reviews converted to sequence of numbers to ensure that they are of the same length. So the pad sequence function adds padding zeros by default to the sequence so that all reviews are exactly 100 words long. If a review is shorter than 100 words, it's padded with zeros at the beginning or end depending on the settings. If a review is longer than 100 words, it is truncated, so it will take only 100 words. So max length 100, this is how we are telling how much words to take. So this specifies that each sequence will either be truncated or padded to 100 words. All sequences will be of same length, which is necessary for feeding the data into neural network. So why are we doing this padding thing? Because in neural network we will require the input of same length. Padding the sequence, then comes the part of building the LSTM model. So as I told you in previous sessions also, this is how it works in TensorFlow. Sequential like this. So you have to pass each layer like this in the sequential manner in TensorFlow. And of course this is not from TensorFlow, this is from Keras, which is part of TensorFlow now. So it is from Keras sequential, and I can say it is from TensorFlow again. So sequential, and these are the layers: embedding layer, LSTM layer, output layer. Where are we getting the LSTM from? LSTM comes from again Keras layer. Okay, so we have embedding, LSTM, and dense, all these from Keras.layers, and I will tell you what they are. So of course the sequential that I told in previous sessions also, the sequential API in Keras allows you to build a linear stack of layers where one layer follows another. It is a straightforward way to create models when each layer feeds into the next sequence. So data comes out from this, goes into next one, goes into next one, like this in sequential manner. And you will see this code. Okay, so this is embedding. Okay, so let's see the embedding layer, how to read this. So the embedding layer converts the integer encoded words from tokenization into dense vectors of fixed size. Instead of representing words as discrete integers, what this means is integers like 1, 2, 3, 4, like that. So the embedding maps each word to a continuous vector in a lower dimensional space. And I told you in a machine learning model you have to do vectorization in a 1D array, one dimensional array, so that you can feed things to machine learning models. To create a machine learning model, you have to convert those things. So these are the some basic concepts how you work in ML. So input underscore dm 5000 means this specifies the size of the vocabulary, that is the top 5000 most frequent words in the data set, as I defined it earlier in the tokenizer. So top 5000 most frequent words, this is how you can give it to this. Then comes the part output underscore dim 128. This is the size of the dense word vector also called embedding dimension. So remember, these are the technical terms: dense, word, vector, embedding, dimension. What they means is simple. So the each word is represented by a vector of 128 dimensions. You can think of this as the number of features used to represent each word. And if you remember, I told you what features are. So layers have different filters and look for the important information, all those things from previous session. So those are the things here it means as features. So input underscore length 100, this defines the length of the input sequences. 100 words per review as determined by padding. The embedding layers need to know how long the sequence are to generate the appropriate shape for its output. So you have to tell it that we are limiting or using the 100 words per review, like this. So these are the three things you have to give. Okay, then comes the LSTM layer. So this was the embedding layer. Now comes the LSTM layer, and I told you in the start of this session what LSTM are. They keep the things in the memory. So the long short-term memory layer is the core of the model that we are building. It processes the sequence of word embeddings and learns long-term dependencies between the words in the review. So LSTM 128, the number 128 represent the number of LSTM units or memory cells. So they are called LSTM units or memory cells in technical terms. Each LSTM unit captures relationship and patterns in the input sequence. Each LSTM unit captures the relationship and patterns in the input sequence. So as you can see, this is new, because earlier whenever we use the algorithm, it was saying that words are not connected with each other, but here it is saying that unit capture relationship and patterns in the input sequence. So this is LSTM. This is different from others. So return underscore sequence false, what this means is this specify the LSTM should only return the output for the last time step, that is the final hidden state. This is because we are performing classification and don't need the intermediate outputs of each time step word in the sequence. So if set to true, the LSTM would return the output at every time step, which is useful for tasks like sequence to sequence models. So if you want to look what is going inside it, you can change this to true, and if you keep this false, because we are just focusing on the output and not the intermediate outputs, so we are looking for the final output. So this is the reason I kept return underscore sequence to false. So I have told you embedding and LSTM. Now comes the dense one. Now comes the dense layer. This is the output layer. So the dense layer is fully connected layer that serves as the output layer, and in previous sessions also I told you about these fully connected layers. So in this case, it is responsible for outputting the final prediction of the sentiment, either positive or negative. Number 1 means the layer has one output unit because it is a binary classification problem. So dense 1 means here the layer has one output unit. Binary classification problem, either 0 or 1. So binary classification problem. Activation sigmod. Sigmod activation functions caches the output to a value between 0 and 1. So as you know, we have used different activation functions in each project because it depends what kind of output we want. Here we want a binary output in the form of 0 and 1. So this is the reason we are using sigmoid activation. So the model will output a probability score that indicates likelihood of the review being positive if the output is closer to 1, or negative if the output is closer to 0. So this is what activation function here means, and in this code you can clearly see I have mentioned all these things here, and I told you what each argument means and why you require these arguments. Then you have this sequential available here, the layers available here. Now how to compile this using this model.compile. So the optimizer is Adam that we are using. So the Adam optimizer is widely used optimization algorithm that adjusts the learning rate during training for faster convergence. Faster. It is popular due to its robustness and adaptability. I think I have used in almost all projects this Adam optimizer. So the loss binary cross entropy loss function is used for binary classification tasks. So why are we using this again and again? Most of the tasks were classification task, as you remember. So this is binary classification task. So it measures the difference between the predicted probabilities and the actual labels. So what we thought it should be, or the model thought it should be, and what should be the final output or actual labels. This is what it means. So we will calculate the loss and all things and see the metrics. I have included the metrics also in this project. So this tells the model to track accuracy during training and evaluation. Accuracy is a useful metrics for binary classification task, showing how often the model makes correct prediction. And of course you will require these charts to see if everything is going right or not, or correctly or not. And if it is not right or correct, you have to change some algorithms, do some cleanup, and then you will get the final output correctly. I will continue this session in next video. See you in next video. Have a nice day.